Thank you. You guys can see me in the back there? I must be like this tall. There's a bit of echo here. That was weird. Okay, yeah, I'm Glenn. So happy to be here. This is my second time speaking in Poland. And I gotta say, you guys are amazing hosts. I've rarely seen anything like what you guys did. So, I know you said that you'll have questions on Twitter and we'll answer them in the panel. If you guys want to ask me something after my talk, come and find me, ask me a question, and you get a prize. I have chocolate. Okay, so I'm going to talk about event-based computing and serverless computing. I hate the term serverless. I put it in there so they would accept my talk. It's a buzzword, everybody likes it. It's meaningless. It means 12 things to 13 different people. But I'm going to say what I think about it. I'm going to first discuss some concepts about this, and then I'm going to talk a little bit about implementation about this, use some tools. The examples I'm using will be tied to Microsoft Azure, because that's what I know, or as Scott says, Azure. That's what I know, that's what my specialty, but the concepts are the same across the different public clouds, and what is possible in one tool, in one cloud, is also possible in the other cloud. So it's just the implementation is slightly different. Let's level set. There's two terms I'm going to be mentioning throughout my talk. Cohesion. The action or fact of forming a united whole. So we can talk about having a high or low cohesion in our software. It means that things that belong together are together. So over here we have things that belong together. They're all gathered in one place. That gives us high cohesion. If things that are connected or belong together are spread all over, we have low cohesion. We want to have a high degree of cohesion. We like that. The other part is coupling, a device for connecting parts of machinery. So coupling is links, hard links between parts of your software. It means whenever you new up something, whenever you have a hard reference to a class or an object or a part of your application, then those two things are connected. We want to have a low number of connections. We want to have low coupling. Okay. So let's define what's commonly a problem, and then we'll see what we can do about it. So when you're building new software, you'll often go to File New. We'll do what we did in school. We'll go to File New. We'll make some product. We'll put in the usual suspects, some infrastructure, some logging, some dependency injection. Get a nice solid foundation to build your app on. It's rock solid. The problem is, your foundation is built to support this, and pretty soon you're building this on top of the same foundation. So, and here's the difference between software engineering and regular engineering, because nobody builds a bridge and then goes, you know, I bet we could land an airplane on that. But they do that with software. Things change, and this is how most people end up with what we call the monolith, the big, super connected application. Have you guys raised your hand if you had this application where you had an area that's like, I don't want to touch that? Yeah? And you're like, I'll move that down the backlog. Yeah. And then you give it to someone else. Let the rookie handle it. And then you get this toxic thing where all the new people coming into your company gets the part of the application nobody wants to touch, because they're not smart enough to say, hell no, yet. So a monolith application, a huge application, isn't inherently bad, but it gives us some problems that we don't really need. It gives us complexity. By nature, as we put stuff into something, complexity increases over time. This is a natural thing. As time passes, the complexity of our application increases. So what we have to do is, throughout the lifetime application, introduce complexity-reducing measures. We have to do things to make the complexity go down. Now, in reality, going unchecked, the complexity will probably increase exponentially. It will go up and faster, and you get to this thing, and now you have the people, devs go, we have to rewrite the whole thing. Throw it away, start from scratch. But why is this? That's because in a large application, each part has multiple couplings. And when you introduce one, you make more multiple couplings, and then you make more, and then you make more, and you end up with this, which is bad. And it's not just in code. It's also in the organization, where the application is going bigger, so we have a bigger team, and we're stepping on each other's toes, so we're separate. Okay, you guys handle that part, you guys handle that part. And then we have people wanting to change things, and they can't because these other guys are working on something else that affects that. And these guys want to deploy, but they can't because these guys are not ready to deploy anymore. And they have different release cycles and different stakeholders pestering them, and it's just a mess. Anyone been here? I have, twice. So what do? These complexity-reducing measures that you speak of, what are these fantastic things? Well, one thing we can do is start dividing our application into multiple pieces. We can make a distributed application. We'll find the elements that are highly cohesive, and we'll split those up. Remember, cohesion, things that are together, belong together, are together. This will be very helpful for different teams, so teams can have different responsibilities. Different parts of the application can be deployed on different cycles. Each team can have their own code, and so on and so forth. So start deciding, okay, how do the different applications talk to each other? Because this thing needs this thing, and then this thing needs to tell this thing that this thing just happened, and it needs to get some information from this other thing. And suddenly you have a distributed monolith with lots of different parts, everybody's talking to each other directly. So you just made things worse. So the problem is we haven't really reduced the coupling. We've identified cohesion, but we haven't really reduced the coupling yet. So the common way of making services talk to each other, which people always reach for, going out is like the basic stuff, is REST. We build a REST interface. So I send a message to this thing. It does some processing and sends me back a reply. Great. Except I have 25 of these, and they all need to talk to each other. And that becomes a problem. And also there's things that happens. What happens if service goes away? Now what do? So the problem is that each service now knows too much about the other services. They have too much knowledge that people, or the services, have to know that, okay, I have to tell this one that, and this one that, and that's called procedural programming, and we were done with that in like the 70s. So again, we fixed the cohesion part, but we haven't fixed the coupling. This is where we have events. So what are events and how do they work? In essence, they are small messages that an application or part of the application can put out somewhere. So I have this little service, and it puts out a message, says something. This just happened. So-and-so just happened. And that's as far as it goes. That's as much as it cares about this. It does not care what happens later. I told you. It's like my mom. I've told you once. She doesn't care that I didn't listen the first time. Except I get smacked for that. And my service don't. But I have another service over here that's listening for that particular kind of message. So it can pick that message up. It's listening for those things to happen. So when it does, that things happen. When this message comes, it can take the appropriate action. And I can have multiple of these messages. These are subscribers. They subscribe to these messages from the big publisher on the right, left? Left. Now here's the beauty part. None of these services have any knowledge about any of the other services. Zero. None of these know that the others exist. Now to be clear, there's a little piece in the middle here. In the middle here, we have our message service. This is the thing that receives our certain messages and gives them, or makes sure that they're delivered to the other interested parties. It keeps track of subscribers, who knows who gets what, who has what, and who has asked for what and didn't receive it. It can retain the messages, and it can persist the messages. So the messenger server sends an acknowledgement to the publisher saying, I have received your message, you're good. And the publisher can just go away. He's no longer needed in this equation. The messenger service has now received the message. This whole process is asynchronous, as opposed to REST, which is synchronous, where in REST, the person calling has to wait for the other end to finish before getting a reply back. If some of the subscribers are offline, they will come online later and will receive the message. In some systems, you can add new subscribers that can go back in history and retrieve the events from before. So, of course, we have this thing in the middle, which can fail, but it's a lot less likely that it will fail. And you can make a lot of measures to make sure it doesn't. You have some of the eventing servers in Azure are now running at 5 nines reliability, which is pretty awesome. They're like down a couple of hours every year. So this is a fire and forget situation where the service will send off a message, forget about it, something will happen with it. But what we often have is that we want some kind of reply. Well, it's easy. We just do 2 messages. We send one message saying, here is something that I would like to happen. I don't know who receives it, or maybe I do know who receives it, or I know that someone might be interested in this, so I'm sending it this way. And it's processed, and the message comes back saying, here's the result of what you previously put out. Now, the service here on your left has an expectation, the publisher has an expectation of something happening, but it has no idea of who's doing it, what service doing it, if it's 1 or 20 services sharing on this. And you can do all sorts of funny stuff here with load balancing. You can have multiple subscribers, there's the same message types, because we can have different types of messages. The messages can have different topics, for instance. That this is one kind of message, and there's another kind of message, and I can choose to subscribe to only these kinds of messages. But there is some overhead. This is not trivial. There is a complexity here that has to be handled, so you might not want to start your application doing this. If you make an application keeping track of your kids' Xbox collection, event-based application might not be the way to go. But since we now can subscribe to different message type or different topics, we can do fire and forget, or we can do let's send something and get something back. And those are different kinds of messages. And we're talking about messages and events have slightly different meanings, those words. And the difference is in the intent of the publisher. So the service publishing this message or event has some kind of expectation or not. What does the publisher want to happen? Does it care at all? What happens? Does it just want to send something out and says, oh, this happened? I don't care. It can be like a 13-year-old child. How was school? Fine. I don't care. The survey goes, this happened. I got this note from my teacher. I don't care. Or you can have an expectation that I will give you this message, I will send this message somewhere, and someone will take care of this. I expect something to happen. It could be a command, it could be a job that would be started, it would be handing a workflow on to some other component. That would be a message. A message will contain information that is of some value. If this information is needed in some kind of process. If this information was lost, then it would be bad. It would be, and if it's lost, if this message disappears in transit, you might not be able to retrieve this information. It is unique. We looked at one with a desire to get a response back. That would be a message. It could be a message of transferring funds from one account to another. It could be a message containing a purchase order saying, this purchase order just went through, and that has to go somewhere, otherwise people are not going to get paid. Which is different from the situation where the publisher has no expectation of a particular thing being done, particular action, or even someone listening to the event. So events only serve to inform. This just happened. It's up to the recipient to figure out what should I do with this information. Now we can also separate events in two categories. We have events about actions carried out by the publisher. I did this, I did that. And we have data points, which are just a stream of information. So the application letting the world know that a customer was created. So the application on the left is some kind of customer system, and we just created a customer. Now we'd send out a message saying, customer so-and-so was created, here's some information about it, if anyone wants it. And we could have different applications listing this event. One could be that it would pick up and place the user, the customer, on some kind of email list. One could be that someone would prepare a physical package to be sent by post to that customer. Welcome to our thing. Or it could be that one service that checks if the customer is eligible for some local promotion or special promotion that we're running. And this is a service that could be set up by a local office just for a couple of weeks and then tore down again. And none of these services know anything about each other. So, those are the concepts. Has anyone followed along on these concepts? Raise your hand. 2, 3, 4 people. Great. Okay. The rest of you go home, take a break. I'll talk to the other 3. So, how can we use this? What tools should we use this? Azure has three different messaging services. They have the service bus, the event grid, and the event hub. They all have their specialties, they all have their use cases. The event hub is for the data point events. It is for taking in a stream of data and processing, ingesting millions of events per second. Taking that in and having a mechanism to put all of those events out to a set of subscribers, and having this load parallelized, being able to ingest huge amounts of events. Storing them into a data lake, for instance, passing them on to a stream analytics job that we can look at data through time. And with data point events and Event Hub, you're not so much interested in the actual different events. You're interested in change over time. You're interested in trends. Is the temperature going up? Is the temperature going down? Did something go from closed to open? Did something go from this angle to this angle? So you're interested in change of state over time. That is the strength of the Event Hub. The Event Grid is for business activity events, where you can have much better filtering and being able to subscribe to particular events, where the events have more data to them, where a subscription might be, there's an assumption here that there will be a large number of different events, while Event Hub will have very similar, events coming into it, of this pretty much the same type. Event Grid is made to handle millions of these very different events and passing them on to registered subscribers. There's an element of authentication here where these events will not go anywhere because these might be business critical information. Service bus is actually the basis of all of this. Event Grid and Event Hub are specialities built on top of Service Bus. A Service Bus is a Swiss Army knife. You can do all this stuff with Service Bus, just a little bit more work, a little bit more complex. But where Service Bus really shines is when you have those business-critical processes that you want to route, that this goes there and this goes there, especially if you want to tie it together with the cloud and the on-premises stuff. That's when you want to pick up the Service Bus. Check time, yep. So let's do some examples. Right now I'm working in the energy business, and we're doing a bit of smart home monitoring and flexibility with power or power consumption. Basically, when people go to work in the morning, there's a surge in the power consumption in a country. There's a power grid goes high, and then it goes down as people are at work. And then they come home and they put on the stove. If you have an electric stove, they put their electric car in the charger. They all kinds of stuff, and then the power consumption goes up again, and then it goes down, and then during the night is probably nothing. This is a problem for different countries. So, has anyone ever seen a BBC series called EastEnders? One person, no, two persons, you guys from the UK. Okay, so this was a famous soap opera in the UK. And everybody watched this. Everybody and their dog watched this. And there's a documentary on this. You can look it up on the intertubes. There was a guy and the British power company. His job was to watch EastEnders. And when there was a commercial break, or a break in EastEnders, he would switch in auxiliary power from France. Because all of England went to put the kettle on to get some hot water for their tea. And there was a massive surge in power consumption because everybody put on this 2,000-watt kettle to boil some water for their tea at the exact same time. And he had to sit and watch it because it was never on the exact same time. So it was actually, okay, there's the break, switch, power from France. And then everyone could have their hot water instead of tearing down the whole electrical grid. So we're working on a project, it's not that complex, but we're working on a project with the EU to find ways of distributing the load back and forth with using solar panels, batteries, we're turning stuff off and on to take these peaks and move them around during the day so we get a flatter power consumption. So we have a couple of things. We have electrical meters in people's homes. We have automatic measuring meters that can send, every 10 seconds, they can send how much power this house has used right now. And we all ingest that into an event hub. This is a data point event stream. All of these goes into Event Hub, and from Event Hub it goes into something called Stream Analytics, which is basically a way of doing SQL queries over time. So what we're doing there is we have a query that will say, get all the data, group it by meter ID, and select and sum up all the consumption values for the past 1 hour from the hour. From the top of the hour to now, sum that up. And then we'll do that every 10 seconds. It will sum all the different meters and output that. So that's an example of using an event hub. We have a different example where we're using Event Grid. In the houses, we have a thermostat that controls how hot do you want your space heater to go. We're basically using floor heating and how hot do you want it to be. So whenever people go and adjust that, tick, 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 whenever they adjust that number, we get an event. And that goes into the event grid, which is a temperature set event. And we have code that subscribes to this event that wants to update what we call a digital twin, which is another term that is completely misused because it means 13 different things to 12 different people. But it's basically, well, let's be honest, it's a JSON file in the cloud that has a bunch of values that represent stuff in the house. So it's a representation of the state of the house, is a JSON file, and we can call it digital twin, and we're cool and hip. So that consumes those data and updates this digital twin, so we have a database that will be accurate in showing how much is the temperature set in each particular house at this point in time. There's also a web API service that subscribes to these events and store them in a data lake for historical analysis. Because we want to maybe do AI training, we want to see how these things work over time and identify trends and stuff, and we don't really know what we want to do with data, so we're just keeping it. So we're just dumping them on data storage. Again, these two things, I have no idea that they exist, that the other entities exist. There's also more examples later, but I'm going to talk a little bit more about just one more thing as well. All of these events are also being subscribed to by an event hub. It's subscribing to events from the event grid and makes a data stream out of this that is shipped to a third-party partner. Now, I'm going to talk a little bit about the code, because I'm going to talk about functions. Serverless, again, it's one of the latest buzzwords. It's right up there with blockchain. And what is it, and what does that have to do with events? Actually, nothing directly, but they fit in nicely. So serverless is basically one more step up the ladder of abstractions. So we're going to talk about Azure Functions, which is the Microsoft Function as a Service offering, or FaaS. There should be a T there. I have no idea why I didn't get that in. So in Azure, in Functions, the way functions work, and this is the same for AWS Lambda, which is called at Amazon, is that you define triggers to your function. And then you write just your function code, and that's basically it. You don't have a website, you don't have an IIS web server, you don't have a startup CSS, you have nothing except for the single function. If you're writing a web API, you just have the one single function. That's it. And then you have triggers, built-in triggers that can trigger your function. These triggers could be, it could be a normal HTTP call. An HTTP call request came in. It can be a timer, basically a cron job, thing every 5 minutes, every 2 minutes, every day at 2 o'clock. It can be a file appearing on Azure Blob Storage. It could be something being changed or written in a Cosmos DB database. It could be an event coming in on the event grid, or an event coming in from Event Hub, or a service bus. It could be a couple of different things. It could also be a webhook thing. And all of those triggers are now taken care of you. You just say, I want this. So here's the header of the function for writing, for reading every time a new file appears on blob storage, it will be read. So the first line here, blob trigger sample images name, whenever you write an image to that sample images, that file will be read. And it will be passed into your function will be called. Then there's 2 more lines, blob sample images SM, sample images MD. So this is the header of a function for taking in pictures and automatically making thumbnails out of those. So if you upload a picture somewhere in your front end, it stores it on blob storage. The upload says, okay, you're good. And then automatically, this function picks up, will be given that image, can create 2 new images on different sizes. And it will just have to set those variables before exiting the function. And the infrastructure around the function will make sure that those 2 files are now being written back to blob storage. Now, the serverless part here is that you can run this on what's called a consumption plan, which means that you tell Azure, you handle the scaling. I don't care. You stepped up in the layer of abstractions. So Azure will then handle your functions. It will send data to your function, and if it's being sent more data to your function than your function can handle, it will spin up additional instances. And it will do that up to 100 instances by default. And each instance can have 10 concurrent sessions by default. And this can be changed. But that's enough for most people. And you pay for the CPU consumption time. So you only pay for the actual time your function is running. This is very good if you have code that is not being called very often. I have one company I was working with where they have shipping containers going around the world with GPS satellite modems on top of them. And every now and again, they will connect up and they will have a GPS on them and they will ping, I am here. And if anyone is watching the news, there's a couple of those on a Maersk ship in the Pacific Ocean somewhere going up in flames right now, so that's fun. So every now and again, one of these messages comes in, and then it doesn't do anything about that. So that comes in as an event to an event grid. There's a function that will pick this up and go, oh, this one is here. Should I do anything about it? Is it within a geofenced zone? Should I notify someone that this has arrived? It does that thing, and then it just goes away. And you don't pay anything until the next event comes in. And this might be a couple or 3 or maybe 4 of these events throughout a day, sometimes. Now, one thing to be aware of if you're starting to do this and you're thinking that this is a really smart idea, let's do this, is a problem called cold starts. Which means the first time you call your function, it needs a little bit of time to spin up. And then it will be kept in memory until it's been idle for about 20 minutes. Then Azure will take it outside and kill it. And then after that 20 minutes has passed, and you have a new call, there will be a new cold start. It's not bad, it's a few seconds, maybe 3, maybe 4. There's been some cases where it's been up to 10 seconds, which is not so bad if it's just a message from a container saying I'm here in an event, but it's bad if you have other service that depends on a quick response. For instance, we made a Slack bot using functions to tell us the menu for the canteen. And the first call every day times out, because it has to respond within 2 seconds. Otherwise, Slack will just go, screw you. So the first call always times out, and then it's up, and then you can ask it. But if your load is relatively even, and you don't need to be hipster and have the serverless, tell people, we're going serverless and stuff, you can put functions on the dedicated app plan, which means you basically say, I want this amount of server. You're no longer serverless, but you still have the functions and all that goodiness that comes with it. So this is a rather nice place to be, actually. I can now write my business logic as a function. I can make it completely self-contained, saying, when this happens, this should happen, and then this comes out the other end. I don't have to, if I'm working on a consumption plan, I don't have to care about scaling. I don't have to care about an app plan. If I'm using the built-in triggers, I don't have to care about any infrastructure. So it makes for us, it's made for really rapid development where we can just add stuff really quickly. And because it forces you to be self-contained, you start thinking about applications in a slightly different way, which makes your applications or your parts of the applications more cohesive, and it reduces your coupling, especially when you combine them with events. Now, important thing to note. Functions and serverless do not cure cancer. This is not the thing that you should go home and says, I'm going to convert my super massive ERP system to functions and events. There are specific use cases where this is really useful, and there's some there's not. So you have to go back to cohesion. Can you put the things that belong together in a small enough package to be able to call it a function or maybe a couple of functions? Or is it too big? So I'm going to take a couple of examples of that as well. Here's an example of a function we have in our stuff. We get an HTTP call from a third-party vendor with a bunch of events. So we have the name of the function on top here. It's like event timer, which is just the part of the URL. And then we have an HTTP trigger attribute to the parameter, the request parameter. It has an authorization level function, which basically means that there's a key, authorization key that has to be part of the HTTP headers when you call this. So it's basically an authentication part. And we have to make it a post message. And then there's just some code for taking some JSON, and then a function that I don't show here because it's not that interesting, but just a function that runs through this JSON that we're getting and converts that to events and toss it out. Now, of course, I could go find a new project, I could write it out, I could add a controller, maybe I'd add some dependency injection for good measure and old habits. I'd add some code for authorization, have to figure that out. I'll configure up some logging, which is, again, out of the box in Azure Functions. And then I'd add some code for publish an event, and I'll do that. Or I could just write this function and nothing else. Has a name on the top, got some parameter, done. It is very self-contained. It does one thing, and it does that one thing very well. There's no fuzz, it's very cohesive. It has no hard couplings other to an event grid where it publishes its messages. So a place where functions really shine for me, and this whole serverless thing, is integrations. So in this smart home project we're on, we don't just read stuff in, we also, from power meters and control heating, but we also control your water boiler, which is one of the most power-hungry pieces of a house, if you have an electric water boiler. Some people have gas, then this is not a problem, but if you have electric water heater, then we want to keep track of that. So that is the consumption meter connected to it, and we don't talk directly to that, some kind of C-wave home automation stuff, and it's connected to a third-party gateway, which we don't control, but they have their own cloud. So it sends events up to a third-party cloud service. Now this third-party cloud service sends events to the function you just saw a piece of. It will, when it has events, it will send them to us as an HTTP post. Here's a bunch of events. This is what happened last time we spoke. We'll get that, process it, push it out, those out on the event hub, tell them, okay, we're done. And then we'll send us a new batch of events. And that's how it keeps going like that. Now these are pushed out on the event bus. So these are vendor-specific events. We have different vendors with different gateways, with different cloud services, with different types of events. So these are vendor-specific events. So we push the vendor-specific events out in the event hub. Happens a bunch of things from those are consumed. They're put on the data grid, data lake, but they are also consumed by another function, which will translate these vendor-specific events to our generic events. Again, one function does one thing, does it great. There's no couplings. All it does is takes in a vendor-specific event, transforms that JSON into a different JSON, and passes it on, which is picked up by another function that will update our digital twin. So it goes through there. For us, it's been very easy to visualize this, very easy to see which part is which part. And every part has been small, relatively small, and relatively well-contained, and we think about these things a little bit differently. It's a little bit harder to mix code about, and that's been a good thing for us. Now we can go the other way as well, because this water heater measure also has a relay where we can turn the water heater on and off. So the digital twin has basically a proxy service which you can get a control signal saying the water heater should go off now. And it will also generate events. It will generate a generic control event saying device so-and-so should be set to the off state. We have different vendors which listen to these different vendor functions that listen to these generic events, and it has a way of looking at the event and determining whether it belongs to that vendor or not. If it doesn't, it's just discarded and we're done. If it does belong to that vendor, it will pass it on to the vendor cloud and then down and control the state of the device. Now, the nice part here is that everything on the left of that line is vendor specific. And everything on the right, and there's a lot more further on the right, which isn't shown here, is generic. And this works because these things are very decoupled. We have our generic data model or our internal data model that we map to. So when we add new vendors or new capabilities, we're adding solar panels, we're adding batteries, we're adding car chargers. We're going to add the possibility of charging your house with your car, which is really good if you can charge your car at work. Because then you can drive your car to work, charge it, come home, and then run your house off your car with enough charge to get to work the next morning, and then charge your car at work again. But adding new models, adding new capabilities for us is now super easy. Because all we have to do is add a small function that talks to that specific vendor, gets the data in or goes and gets it, and puts it out in the event grid. And if we want to do some transformation, we make a little function that does just that, put it there, grab it from there, put it there. And once it's generic events, so we had one battery type, one vendor for batteries, and now we're getting another vendor for batteries, and all we have to do is make two functions and one event topic. And we push the same data in throughout the whole application. So one of the things there that is not function-based is our device twin. Device twin is a bigger application. It has a lot of internal state. It has a database. It has a more significant API. It has a bunch of logic into it. It has some internal storage as well in the database. It has actually two different kinds of databases. There's a graph database, which is also very cool and hipster. And if you want to make a talk about graph databases. But the cool things here is that the functions have saved us from a lot of work, and we can focus on the work that actually matter to us, instead of focusing a lot of infrastructure and boring stuff. So, to summarize, splitting your application up and communicating with events instead of directly can give you better cohesion and a lower coupling in your application. Using functions as a service can give you some advantages by removing the need for infrastructure code. The best code you have is the code you didn't write. The code you didn't write will never fail. It will never crash and will never become obsolete. It will never be in the way. It will never become legacy code. And serverless hosting gives you a couple of things less to worry about, has some benefits, and it gives you a couple other things to worry about. So your mileage may vary here. You have to decide whether these things are more worth worrying about than these things. So that was it for me. If you want to reach out to me, you can find me there. I'll be around here somewhere during the day. Like I said, if you come up to me and ask me questions, you get chocolate. Shameless bribe. Okay, I'm done. Thank you.